That's page 11. And really, I'm not going to say much because I only got 3 minutes anyway. But these rules here, this looks like mumbo jumbo, black magic, whatever. It's really pre-calc. The other rules, if you don't recognize these as being something we learned in this course, then I'd say you probably need to study a little bit more, because this is stuff that we talked about in the last unit. What you want to do is at least attempt to commit these to memory, because these are very, very important, critically important, right? And they're not formulas that you'll be given. So take some time this weekend and try to memorize these. Flashcards end up being very, very useful. That's actually the only thing I wanted to talk to you about, definitely. Okay, so we started off the process by using they call it the alternate definition of a limit. We call it the better one. Okay, which ended up being the limit as x approached a of sine of x minus sine of a over x minus a. And I went into this whole thing about how trig functions are really ratios, and those ratios almost always involve radicals. So sine x minus sine a could be thought of as a radical expression, right? And when you have the sum or difference of radical expressions, one thing that you could do is multiply by a conjugate. So we multiplied top and bottom by the sine of x plus the sine of a. All right, so that gave us limit as x approached a. It's the conjugates create difference of perfect squares, so lots of stuff should cancel out. In this case, we end up with sine squared x minus sine squared a over x minus a times the sine of x plus the sine of a. All right, so then the bell rang. Flash forward 2 days, and here we are. Right? So the question comes down to, well, what do we do with this? Right? We have some identities above that can be helpful for us. Right? And so we're going to look at some of those. I just want to make sure, because I just told you to study them, I want to make sure the right ones are there. Okay, yeah, sum and difference identities. This is actually going to be working backwards, and it might be a sort of a moment where you're like, whoa, I never would have thought to do that. But that's why I'm up here explaining it. Okay? So this is, if I thought it was something that you could have done on your own, based on your knowledge base, then I wouldn't be up here telling you how to do it. Right? So yeah, we need to be able to simplify this. Some of the things that we have in our arsenal are like identities. Like for example, sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. So some things like that. But we want to focus on the ones that I indicated above.
So maybe a dumb question, but why can't you just factor out the sine and then have x minus a times sine and cancel out the x minus a's?
You can only factor when you're dealing with multiplication as an operation. Since that's not sine times x, we can't factor. It's sine of x.
Oh.
Okay, so it's the sine function of the ratio x. Okay, so unfortunately, that's not something that we can do. So, what can we do? Well, let's do a little pre-calc work here, and I'll show you the relationship. I'm just going to kind of do it off in no man's land here. I have, unfortunately for you, infinite workspace. So you could find some space to write this down, or you can take a picture of it when I'm done. I mean, it's getting posted online anyway, so it doesn't make a difference. So we have this expression here is the product of sine x plus a and the sine of x minus a. It's not something that a person would normally look to do, but we'll play it out and I'll show you how things actually work. It's kind of a cool relationship, but again, not the kind of thing that you'd necessarily come up with on your own. Right, so we have the sum identity for sine, which tells us that sine of x plus a is the same as sine of x cosine of a plus cosine of x times the sine of a. All right, that's that sum identity. So if I were to have, I'll just write it in general terms, sine of a plus b, it's sine a cosine b plus cosine a sine b. All right, and so in this case, it's instead of an a, it's an x, and instead of the b, it's an a. Okay. I don't know, depending on your pre-calc teacher, or GAP, I don't know. You may or may not have had formula sheets when you're dealing with trig stuff. In Algebra 2, I understand having formula sheets, but at some point, in order to understand the intuition in calculus, you really need to commit some of these things to memory. And so knowing that this translates into that allows you to even identify this as a possibility, you know, as a possible substitution before you even get started on a problem, right? If you don't know this relationship, then stuff like this never really even occurs to you, right? It's really kind of a double-edged sword, because on a test you want these formulas desperately, but it doesn't help you in the long run. Minus cosine x sine a. All right, the other variation, we have the sum identity for sines, but we also have a difference identity. Sine of a minus b, sine a cosine b, minus cosine a sine b. Also with the a value being x and the b value being lowercase a. All right, so what I'm doing here is multiplying these two things together. When we multiply, because it's the difference of squares, we're looking at conjugates. We're really just multiplying this against this. Sine squared x cosine squared a. And I'll go black. Minus cosine squared x sine squared a.
That it?
No. There's more fun.
I just want to, just where I need to put this.
There's loose leaf paper in the back. Probably have your own notebooks and stuff too. All right, so I wanted to swap out, if you go back to the actual limit, the last thing we wrote in the limit form, I need to swap out a sine squared x and a sine squared a. But I have cosines here, so I want those to go away. So let's make that happen. What can I replace cosine squared a with? 1 minus sine squared a. And we would do the same thing with the other cosine, 1 minus cosine squared x. 1 minus sine squared x, I mean. Okay, so distribute in both cases, and something sort of magical will happen. Sine squared x minus sine squared x sine squared a minus sine squared a plus sine squared x sine squared a. So for that last part, I distributed the negative and the sine squared a to each terms, but I did it simultaneously. All right, when you take care of that next step, this last step here, what happens?
Cancel.
Yeah, we have parts that cancel out, and fortunately, they're the most complicated parts. So sine squared x minus sine squared a is what that initial expression is equivalent to. All right, this was probably given to you at some point in pre-calc, if I remember correctly, because I did the same thing when I taught pre-calc that I do here. For every unit, I hand out a massive packet and we work through it. And when we did trig identity verifications, this was almost certainly one of them. And so it would be verify the following identity. It would be this equals that. Right? And then you have to work through this algebraically to get left equal right. Right? So the reason why this is important is because going back to this, we can now swap out the numerator. All right, that's equivalent to the sine of x plus a times the sine of x minus a. All right. It's at this point that we're pretty much done with the problem. And when you look at the steps that we wrote here for limits, it looks like, oh, there's only like 4 or 5 steps, plus the 100 steps in side work. Now, you don't have to show all of this stuff. You can just know this information. All right? You can know it in your head or you can know it in your calculator's memory. Right, so either way, we can assume this substitution. All right, so it's not something that you actually have to solve out every time. So if that's concerning, and I would be concerned too, then it's not something you need to worry about. Part of this will actually cancel away. I'm going to rewrite it so it's a little bit more obvious. I'm going to put these two together in their own fraction. All right, so what does this part become? 1. All right, that's one of our rules above. It's that sine of a over a model. All right, as long as what's contained within the sine matches the thing on the bottom, then you're in good shape. You can cancel that to 1. All right, so that's a variation of this rule. So now, really, the troublemaker's gone. Because if I replaced an x with an a or an a with an x here, that's what was making it undefined, or in this case, indeterminate. So now I can do my substitution. So I'm looking at sine of 2x over 2 sine of x. All right, I'm replacing each a with an x. So I'd have an x plus x, which is 2x. Sine x plus sine x is, we would have 2 of those sine x's. All right. There actually is a simpler answer. Much simpler. This is an identity. Does anybody know what sine of 2x is equivalent to?
2 sine x plus sine x.
Exactamundo. So now we have a common factor that can be canceled, and we arrive at just cosine of x. All right, so that's pretty beefy. There's a lot going on there. So it's one of those things, like, if you thought this stuff was hard before Trig, it's like, oh, it's crazy. But we're gonna spend some time reviewing
The
and
derivative
learning.
of sine of x is just cosine of x?
Correct. Correct.
Where's the shortcut?
The shortcut is memorizing that fact.
Oh, that's, okay, so you now have to do that again?
Well, you gotta be prepared to have to do
What's that again?
a problem like this on a test, but just the one time, yeah. So let's do another one. This time we'll deal with cosine of x. All right, so limit as x approaches a of f of x, which would be cosine x, minus f of a, which is cosine a, over x minus a. We'll do the conjugate again. So we're going to multiply top and bottom by cosine x plus cosine a. So we'll have cosine squared x minus cosine squared a over all that stuff. So now we have to figure out the top. All right. So we could use a similar idea to what we did on the previous problem. So let's just take a wild guess here. And I'll show you how you can verify your wild guess. Let's assume that it's exactly the same idea. Cosine x plus a, cosine x minus a. All over that stuff. And if it's not, I'll make an adjustment. But this is what you would do during a test, hopefully, if you're in a jam and you're not really sure. Use your calculator to help you verify the identity, or that is in fact an identity. All right, the issue is that we have an x and an a, but the calculator can handle that. It's not in the form of a graph. Right, so what I want to do is I want to test to see if cosine squared x minus cosine squared a is the same as that, cosine x plus a, cosine x minus a. All right, the equal sign you get in the second math menu. All right, oh, and also, for some reason, the calculator thinks that this is cosine squared x. I don't know why. It's not, but that's what it thinks. All right, so cosine x, close it up squared, minus cosine a, close it up squared, equals, second math, option 1,
How'd you get it?
alpha math. Cosine x plus a, cosine x minus a. All right, this is testing the logic, so it's going to give us a true or false. If it gives us a 0, it means that it's false. If it gives us a 1, it means that it's a true statement. Right, so that's false. Right, so what we want to do is start tweaking this to see if we can get it to work. Maybe change one of them into a sign. Still false. Maybe change and then you could play around with negatives. But there is a way to handle a kind of question like this if you have an issue where you're not getting a relationship that holds up, right? And that would be to use the other difference quotient, right? And actually, it might be better off for you, I'm just thinking out loud. If you use the other one, you can do a direct substitution without having to, I mean, you're basically going this way to this way rather than from here to here. So maybe we will do it that way, rather than play around with this. So, okay. Let me just show you what that looks like, and then I'll tell you what the correct multiplier was. But I want to see if you can figure it out. So you'd use this method. This is the one we try to stay away from because it's usually more complicated. And in this case, you'll see it'll get really nasty before it gets not too bad. All right, so the f of x plus h is really just taking your original function and replacing the x with an x plus h. And you know what, after I go through this, because you saw a complete solution for sine, just tell me which method you like better, and then I'll just go with that. Because I keep telling you what way I like to do it. You should probably get a sense of what way you like to do it. So this part, the cosine x plus h, is the part that if you're going to get jammed up, this is where it's going to happen. Hopefully that's not ever going to be the case. All right, this is the sum rule for cosines. All right, so you can look above, but it's cosine, I do that often, cosine x, cosine h minus sine x, sine h, minus the cosine that's already there, minus the, divided by the h that's already there, with a limit. Because after this, the algebra should work itself out pretty nicely. So again, this is the difference identity, the sum identity for cosine. Cosine a plus b, cosine a, cosine b, minus, it's weird, but it has a minus in it, sine a, sine b. All right. And so, this is the part that gets a little funky. We need to regroup and try to break up our fraction in a reasonable sort of way. I think one thing that might be obvious is if I'm going to regroup, maybe put the cosines together. And if I'm going to make them their own fraction, I could do that all in one shot. I could say cosine x, cosine h, minus cosine of x, all over h. Then, separately from that, I could say sine x, sine h, over h. When you get to this step, this is where things start to clean up. All right, so it got pretty nasty, but now it's going to start getting a lot nicer. Because in that first fraction, I have a GCF of cosine. So I'm going to rewrite. I'll put the cosine in front of the entire fraction, just to make it obvious what's left over. Cosine h minus 1 over h. And I'm going to rewrite the second one with the sine of x in front of sine h over h. All right, you still got to know stuff using this method. You're not off the hook, you need to know identities. But this time, instead of distributing, we're going the other way in factoring. So depending on your strengths, this might be the way to go. All right? In this case, you know, if this process doesn't bear out an answer for you, then it's the only way to go. All right? So, limit as h approaches 0, cosine h minus 1 over h. What is that equivalent to? 0. All right, so that's telling me that this whole thing zeroes out, which means this entire first expression is going to 0. The sine h over h we know is going to 1. So we get a negative sine x as a result. So it's still a limit. Well, actually, I kind of applied the limit, but I'll write it anyway. So 0 minus the sine of x. So it's the limit as h approaches 0 of negative sine of x, which is just going to be negative sine of x, because there's nowhere to plug in an h, or a value for h. So it's just that. So what we get from this, I mean, it's going to be a fact that you're going to have to know at some point, but the derivative of cosine is equal to negative sine, right? So, and you're going to need to know those derivatives, so sine, cosine, tangent, all 6 of them. So, you know, but this is the building blocks.
Is there no way to do it the other way, like with the x factor?
You have to find the multipliers that work. So it could be a matter of switching the x and the a. There's a lot of different possibilities. So maybe you have to play around with it in order to come up with a relationship.
So like on a test where you can decide which one to use?
Right. Yeah. So the question will say use a limit definition to get whatever answer, and you can decide which method you like. Yeah, sure. Sine of 2 times x plus h. I'm going to put it in an extra set of parentheses just so it's really clear that that's still part of the sine function, or at least as clear as I can make it, minus the sine of 2x all over h. All right. So then we would do limit as h approaches 0. I'm going to distribute within the set of parentheses to clean it up a little bit. Sine 2x plus 2h minus the sine of 2x all over h. Once you make that move, it becomes like the problem that we did on the previous page, where we have a sum of 2 components within the sine function. So now it's just a matter of applying the appropriate identity. So the limit as h approaches 0 of sine of 2x cosine 2h plus cosine 2x sine 2h minus the sine of 2x all over h. So it has the same structure as all the stuff on the previous page. So we want to do something similar to what we did on the previous page also. So we want to group together any parts that would be factorable by a GCF. The cosine 2x sine 2h isn't really common to anything else. It's got the same ingredients, but if I group the middle term with either of the 2 outer terms, I'm not going to be able to pull out a GCF. But I will be able to pull out a GCF if I group these 2 together. So sine 2x cosine 2h minus sine of 2x. I'm going to put that over an h. Then we're going to have plus cosine 2x sine 2h also over h. All right, so we just have to make some minor adjustments here and we'll have it. Because, or at least looking at the black one here, I have sine 2h over just an h. I'd like that to be sine of 2h over 2h in order to meet the standards in the model. Right? So I'm going to multiply top and bottom by 2. And that's going to happen in both cases. All right, so you can distribute through the 2 if you want, or you just kind of leave it off. It really off on the side in the numerator. It really doesn't make a difference. but you do want to multiply it by the h on the bottom. All right, so I'm looking at limit as h approaches 0. I'm going to leave it out. And in fact, I'm going to do more than that. I have my GCF here. I'm going to pull that out and group it with the 2. So it's going to be 2 times the sine of 2x. And that'll be cosine 2h minus 1 over 2h. And then same idea for the other one. I'll put them together. The 2 along with the cosine. Let me get this out of here. So plus 2 cosine 2x multiplied by sine 2h over 2h. All right, so the first fraction goes to what? 0. The second one goes to what? 1. So we're looking at the limit as h approaches 0 of really just 2 cosine 2x. So that's going to give us a result of 2 cosine 2x. All right, now there's a shortcut in there. If you compare what you start with and what you end up with, you get the makings of that shortcut. So try number 4. Go through the process. You'll see what the answer is there, and then you'll be able to determine, oh, this is the shortcut. So try that, and then complete the table. So between today and tomorrow, because we're down to the end.